చాక్లెట్ వాసన లేకపోతే నువ్వు పోయి గాగుల్స్ సాక్స్ వేసి అయిపోయి దానికి ఇంతమంది
Good evening, participants. We'll be waiting for a minute or two to join. We'll see the participants. We'll wait for a few more minutes for the other participants to join, and then we'll start off with the inaugural session. Good evening, participants. Now we'll be formally starting with the inaugural session of the Faculty Development Program on Advancements in Sustainable Energy Management and Environmental Protection. On behalf of Maulana Azad National Urdu University, Polytechnic, Hyderabad, I welcome Professor Syed Ainul Hassan, Honorable Vice Chancellor, Maulana Azad National Urdu University, Professor Abdul Wahid, Dean, School of Technology, Maulana Azad National Urdu University, Dr. Muhammad Yusuf Khan, Principal, Polytechnic, Maulana Azad National Urdu University, and our dear participants. Welcome to this Faculty Development Program sponsored by AICTE Training and Learning Academy, ATAL Academy, on sustainable advancements in sustainable energy management and environmental protection. The participants of this FDP are from various departments like Electronics and Communication Engineering, Computer Science, Mechanical, Electrical, Civil, and from across the India. I extend a warm welcome to all the participants. For this FDP sponsored by ATAL, let me first introduce our coordinator for this program, Dr. Muhammad Yusuf Khan, Principal, Maulana Azad National Urdu University, Polytechnic, Hyderabad. He has meticulously planned all the sessions of the FDP. There will be 13 sessions in this 6-day-long online faculty development program. Our team here at Maulana Azad National Urdu University, Polytechnic, Hyderabad comprises of a coordinator, Dr. Muhammad Yusuf Khan, myself, the co-coordinator for the FDP, along with our organizing team consists of Professor Z. Abdul Rahim, Professor Arshia Azam, Ms. Ismat Fatima, Ms. Safia Sheikh, Ms. Nida Yasmin, Dr. Zina Tara, Mr. Likhaur Rahman Khan, Mr. Rakesh, Dr. Pathan Muhammad Aziz Khan, and Mr. Syed Farman Ahmed. This 6-day-long FDP will have 2 sessions daily. They'll be starting from 6 o'clock to 9 p.m., 6 p.m. to 9 p.m. Daily we'll be having 2 sessions. And on the last day of the FDP, which is on the 6th day, we'll be having 3 sessions starting from 2 p.m. to 8 p.m. And the last day, the 3 sessions will be followed by assessment and feedback from the participants. As you might be knowing, the criteria to get the certificate of this FDP is a minimum of 80% of the attendance need to be is mandatory, and at the end of the FDP, assessment will be conducted. Minimum of 70% of marks in the assessment are compulsory to get the certificate. And we have a very eminent speakers from academia and industry related to this concerned topic. The objectives of this FDP on advancements in sustainable energy management and environmental protection is to equip faculty with knowledge on recent innovations and practices in sustainable energy. The program aims to deepen understanding of energy conservation, renewable energy technologies, and eco-friendly strategies that support environmental protection. By exploring interdisciplinary approaches, it encourages participants to adapt and integrate sustainable solutions in their teaching and research. Through expert sessions and case studies, the FDP also aims to develop skills to integrate energy-efficient technologies and sustainable practices, empowering educators towards sustainable development and contribute to a greener future through their educational impact. The expected outcomes of this 6-day-long FDP include an enhanced understanding among faculty of sustainable energy principles, renewable energy technologies, and environmental protection strategies. Participants will gain practical insights into energy-efficient practices, enabling them to incorporate these practices into their teaching, research, and community initiatives. This FDP aims to foster interdisciplinary collaboration and empower educators to serve as advocates for sustainable development, contributing to institutional goals and broader environmental impact. Now I request the principal Maulana Azad National Urdu University, Polytechnic, Hyderabad, Dr. Muhammad Yusuf Khan, the coordinator, the FDP coordinator, to address the August gathering with his valuable insights.
Respected Honorable Vice Chancellor, Maulana Azad National University, Professor Syed Ainul Hasan sir. Very good evening to all the participants. Dear esteemed participants, it is my pleasure to welcome you all to the 6-day AICT ATAL-sponsored online faculty development program on advancements in sustainable energy management and environmental protection, which is being organized by Maulana Azad National University, Polytechnic, Hyderabad. In today's world, sustainable energy practices and environmental protection are not just choices, but essential responsibilities. This FDP aims to provide a platform for knowledge sharing, innovative ideas, and meaningful discussions on emerging trends and technologies in sustainable energy and environmental protection. Sustainable energy management is important for a greener and more resilient future. We have gathered experts and thought leaders to guide us through insightful sessions, equipping us with the tools and knowledge to drive positive change in our respective domains. I encourage each of you to actively participate, exchange ideas, and make the most of this learning opportunity. Wishing you all an enriching and productive FDP experience. Thank you.
Thank you, sir. Thank you for your valuable insights. Now I request Honorable Vice Chancellor, Professor Syed Ainul Hasan sir, to give his presidential address. So your mic is mute, might be. No, it's okay.
Thank you, Professor Fatima, and most of the participants. As you know, I'm not directly, associated with this study, but yes, being part of this environment, I must say that as far as awareness part is concerned, well, I'm also a member. As a matter of fact, now much talk is going on throughout the globe regarding environmental protection and sustainable energy development. Now, what is happening? Long back, I submitted one project to UGC where I discussed on the basis of my literary understanding, not exactly scientific, but yet literary understanding. I submitted a project on environmental and ecological awareness. And on the basis of my own research and understanding about the environment, I tried my level best for the last 3 years as Vice Chancellor of the university to create a congenial environment for energy saving. Biodiversity is one area where we have focused on. But there are many other areas where we can develop on and we can bring the best brain to the forefront. We know that in a given circumstances, there are certain misunderstandings also, some overlappings also. But these overlappings can be curtailed by putting heads together. Individually, of course, we can have n number of campaigns, but collectively, we can do something active. And how to do it? Rather, creating a restricted environment may not be very conducive for academic study. But, well, entrusting responsibilities with the stakeholders can really serve the purpose. And I believe something we take very casually. Casually in the sense that when we are making use of electricity or power, we should also see to what extent we can make use. Because we cannot create a total artificial environment around. We must take help from natural environment. What is happening that yes, during summer and hot summers, what we do, we somehow surrender ourselves before the machine. ACs are on. But let us see how much energy these ACs are consuming. And what are the other effects on our health? These two, if we can curtail and we could bring a solution to it, that will serve the purpose. On one hand, we can have a clean environment. On the other hand, we can have better health. For instance, I was in UAE and it was pretty hot. It was 50-degree temperature, and that too very humid climate. So as long as I was sitting in a car, because I was taken to a beach, I mean, as local people wanted me to see the arrangements they have made the seashore. But it was very difficult for me to bear the heat. So I refused to, prolong my stay there. Rather, I asked these people, please go and have a glance, but I will sit in my car. This is somehow a correlation is required. What is happening that on one hand, the level of pollution, or you can say created by these machines, spreading all over. On the other hand, human souls. If these two are not balanced, ultimately a disastrous situation will appear. This is my understanding. And this is a student of statistics biology. I'm glad to know that for a period of time, say last 2.5 years, Maulana Azad National Urdu University received 2 big awards. One water conservation ministry, the other one green environment ministry, local ministry, and one central government. These things encourage us to move forward. And that's how we have, it's not artificial. It's a natural biodiversity on just in the heart of this Manu main campus. And it has become the center of it. I'm sure that with the help and support of many other stakeholders, we can create similar kind of environment elsewhere. I'm glad that you are organizing a conference an assembly of scholars, learners, experienced people to deliberate upon this issue. I'm sure if you continue this effort, somewhat you would be able to leave behind a good environment for generations to. Thank you. Thank you for inviting me, allowing me to participate in. Thank you.
Thank you, sir. Thank you for taking out valuable time from your busy schedule. And thank you, sir. Thank you for your valuable suggestions and insights into this topic of advancements in sustainable energy management and environmental protection. Now I'd like to request Professor Abdul Wahid, sir, Dean, School of Technology, to give his address.
Thank you, Hajira.
Thank you,
In
sir.
fact, after Vice Chancellor, there is no way to give any kind of address. कोई बात नहीं. Honorable Vice Chancellor, Professor Syed Ainul Hasan, Manu, Principal Polytechnic, Dr. Yusuf Khan Saab, Mrs. Hajira Fatima, FDP Coordinator, dear participants, good evening, Adab. Nowadays, this is very much emerging issue and research aspect in sustainable energy with environment protection. In aspect of climate changes and energy management. In fact, as Honorable Vice Chancellor said, our university is doing a lot of in this direction, in real world, not artificially intelligent, under the guidance of Vice Chancellor. I hope participants will be benefited and identify some new research problems after attending this FDP. I must congratulate and best wishes to participants and organizer Polytechnic Hyderabad. Thank you very much.
Thank you, sir. Thank you so much. Now I request the Vice Principal, Polytechnic, Maulana Azad National Urdu University, Dr. Abdul Rahim, sir, to propose vote of thanks.
Thank you, Madam. I, Dr. Z. Abdul Rahim, Vice Principal, Manu Polytechnic, Hyderabad, thank Professor Syed Ainul Hasan, sir, Honorable Vice Chancellor, Maulana Azad National Urdu University, for his presidential address. Indeed, whatever sir has said has to be incorporated in our professional life. His speech was very informative and knowledgeable related to our current program on advancements in sustainable energy management and environmental protection. Thank you, sir. And I also thank Professor Abdul Wahid, sir, Dean, School of Technology, Maulana Azad National Urdu University, for his valuable address. It's our privilege that All India Council for Technical Education, Training and Learning Academy has selected our esteemed university to conduct this 6-day online faculty development program on emerging topic advancements in sustainable energy management and environmental protection. Also, I thank Muhammad Yusuf Khan, Principal, Manu Polytechnic, Maulana Azad National Urdu University, Hyderabad, Program Coordinator, for his welcome note. Also, I thank Mrs. Hajira Fatima, Course Co-Coordinator, and entire organizing team members for their restless effort in organizing this faculty program. Finally, I once again welcome and thank all the respected participants across the India who has enrolled for this faculty program. Thank you for giving me this opportunity. Now I request Hazra Madam, Course Co-Coordinate, to proceed with the program. Thank you.
Thank you, sir. Thank you, Rahim, sir. Thank you so much. So, dear participants, here we'll end with the inaugural session of the FDP on advancements in sustainable energy management and environmental protection. Now we'll start off with the first session. Let me introduce you the speaker for the first session. And it is my privilege to introduce a distinguished speaker for this session, Dr. Mohammad Yusuf Khan, currently serving as the principal of the Polytechnic at Maulana Azad National Urdu University, Hyderabad. Dr. Khan holds a PhD in Electronics and Communication Engineering, specializing in wireless communication, and has over 2 decades of rich academic and administrative experience. His illustrious career includes leadership roles such as member of ATAL Incubation Center of Niti Aayog and chairperson for AICTE-CII. An accomplished researcher, Dr. Khan has numerous publications to his credit in areas like signal processing, artificial intelligence, and wireless networks. His notable achievements include representing India in international programs such as Study of United States Institutes and the United Kingdom India Educational Research Initiative. Dr. Khan's dedication to innovation is exemplified by his patented work in fuel tracking systems. He is also a member of esteemed professional bodies like IEEE, ISTE, and the Institution of Engineers. We are honored to have such a dynamic and accomplished academic leader with us today. Thank you, Dr. Khan, for joining us today and for gracing this program with your presence. We are all eager to hear your insights and learn from your extensive expertise in sustainable energy management and environmental protection. Without further ado, I would like to invite you, Dr. Mohammad Yusuf Khan, sir, to kindly take over the session. Thank you, sir.
Thank you, Haja Fatima Madam, Assistant Professor, Maulana Azad National University and Polytechnic Hyderabad. We'll start with the session. Okay, let me start with the session. So today's first session topic is Introduction to Sustainable Energy Management. The contents of my presentation are, we'll start with the introduction. What is energy management, sustainable? How do you do? What is the difference between energy management and sustainable energy? The key principles involved in sustainable energy, types of sustainable energy sources, and benefits of sustainable energy management, challenges in sustainable energy management, the role of education institutions in sustainable energy management development, and of course the future prospects of sustainable energy management. And we'll take some of the case studies of India's sustainable energy management. So let us start with, first we'll start with we'll understand what is energy management. So whatever might be a process, a systematic process, which is to be controlled, which is to be monitored, controlled, and optimized in order to minimize the cost and environmental impact. For example, let us take an example of an industry or a factory or an organization where we have a CFL, that is compact electronic fluorescent lamps. If you go for that, the efficiency will be very less, the cost is high, and if you replace these CFL bulbs with light emitting diodes, the efficiency, energy efficiency, that is with the minimum input, maximum brightness you'll get, and the span of LED is 50,000 hours when compared to CFL, that is compact electronic fluorescent lamp, whereas the span of CFL lamps or bulbs are 8,000 to 15,000 hours only. And the efficiency of CFL lamps are less when compared to LED bulbs and LED lamps. Therefore, like this, we can have a systematic control, monitor, and optimization of the energy sources, energy which is available in a particular organization or institution. So that is an example of energy management. Definitely, when you go for the energy management, we needs to understand the goals. For example, the first and foremost thing is there should be reduce energy consumption, efficiency. Yeah, efficiency have to be improved, and the cost should be low. Now, compared to LED CFL, initial cost of CFL bulbs are low when compared to LED, but when you go for the long term, the cost of LED will be, you can say, a reasonable cost, and minimize environmental impact. Definitely, when you consider LED, there is a very less environmental impact, or you can say zero environmental impact. Whereas if you go for CFL, in CFL we have the tube wherein we have mercury. When it is broken, the mercury, it will be hazardous and it will be having environmental impact. So these are the main factors to be considered when you are going for the energy management. And whenever you are going for the energy management, you have to consider the minimum cost, that is the economic sustainability and environmental impact. Now, these are the leading countries which are excelling in energy efficiency. We have Japan, we have Germany, advanced energy audits, South Korea, where we have smart energy grids. Now, when we have understood the term energy management, let us take what do you mean by sustainable. So whatever the process is there in energy management, that is monitoring, controlling, and optimization, same things are there, but here in sustainable, the systematic procedure, the procedure will be for the long time, or long time durability. Whatever the energy management is there, that management should last for longer time. That is known as sustainable. When you consider for sustainable, there are three important factors in sustainability. That is, we have to consider the environmental sustainability, wherein there should be no environmental degradation or an impact on the environment. Second, that is the economic sustainability. That is the cost effectiveness. Whenever you go for the long-term energy management, the cost, there should be minimum cost effective. Then we have social sustainability. The standard of living standard should be improved, and it should be of social equity and well-being for all members of the society. So these are the three important factors for a systematic process to go for a long-term process, for a durable process. That is known as sustainable. Now, sustainable energy, in fact, it plays a key role in decarbonizing. We'll see in the upcoming next slides, decarbonizing, what is meant by decarbonizing, what is meant by greenhouse gas emission. So sustainability reduces the dependence on fossil fuels. So nowadays we are going for the renewable energy. Therefore, dependence on fossil fuels is getting reduced, and it also creates millions of jobs around the world. The sustainable energy is the future, wherein many jobs are to be generated. A future for environmental responsibility, to improve our quality of life, and for its contribution to economy, among other reasons. That sustainable energy management involves, just to have given the example of energy management, now we have come to the term sustainable energy management, which involves managing the energy. If you take the electricity, the production, the distribution, and the consumption, it has to be managed, and it should be through a long term. and without affecting or with minimum effect on environment and meeting the energy demands. That is sustainable energy management. The core focus areas are, whenever you go for sustainable energy management, we think about renewable energy sources. Renewable means reusable energy sources, energy efficiency technologies, wherein low input, output will be high. I have given the example of LED, which requires low input supply and the brightness, the output is very high. Reduce dependency on fossil fuels. Definitely, naturally, when you go for the renewable energy sources, dependency on fossil fuels will be less. And in fact, we have sustainable technologies. Here, the key goals are long-term energy security, environmental sustainability, economic affordability. The countries which are leading in sustainable energy management is Sweden, wherein almost 60% of energy they are extracting from renewable energy sources. Then comes the Denmark. They are using extensive wind energy, known as hydropower energy adoption. Portugal, 100% renewable energy on certain days. Now, the key principles of certain sustainable energy management. Key principles, these are the key principles. Energy efficiency, just now I've said, maximum output while minimizing the energy consumption. Use of renewable resources. Renewable resources are, renewable means which can reoccur, which can be regrown, which can be reutilized. We have that are solar, wind, hydro, and biomass, then ocean winds, you can say, instead of fossil fuels. Environmental responsibility means without polluting the environment. It depends upon, again, the solar, wind, hydro, and biomass instead of fossil fuels. Economic viability, cost effective. Yeah, it should be cost effective. It should not be cost escalating. It should be cost effective. Innovation technology, because of the digitization of grids, which are known as smart grids or microgrids, offset grids, we can go for the IoT-based monitoring system or AI-based monitoring systems. Then we have every country, each country has its own government regulations for cleaner and energy adoption. Policies are there. The policy support should be there. The countries which are excelling in the key principles of sustainable energy management are Germany. Energy efficiency and policies, they have a very rigid, strong policies. Government policies are there for energy conservation, renewable energy. Netherlands, wind energy leadership, they are known as. China, massive solar and wind power projects. The types of sustainable energy sources, there can be many types, but let's see the main important ones. We have wind energy. The energy or electricity can be extracted, can be harnessed from wind, or in solar, the energy can be extracted from the sunlight. In geothermal, the energy is extracted from the inner layers of earth. And in biomass, you can see the energy is extracted from the organic matter of plants and animals. Then we can extract the energy or electricity, you can say, from flowing water. Let's take one by one, and I'll give a small, brief introduction of, you can see the small videos of each one. Let us take the first one. Solar energy is one of the type of renewable energy sources wherein we utilize or harness sunlight using photovoltaic panels. Solar energy is utilized from the sunlight to generate electricity. Okay, so because of this solar energy, we can promote the environmental sustainability. We can have solar energy can be recreated, regrown, reusable. Okay, let's see one small video. Let's understand this solar energy, renewable energy.
Sir, we are not getting any audio of these videos.
Audio. Okay. Audio. Now, is it audible?
No, sir, just a video is getting played.
Audible?
No, sir.
Now it's audible?
No, sir.
It's audible, sir.
Okay. Thank you.
मेरे को audible है.
Sir, only you are audible. The video voice is not audible.
We can hear you, but not the video, sir.
आगे. आ रही बोला बस.
Audio नहीं आ रहा सर.
Hmm?
Audio is not listening.
आवाज नहीं आ रही. सुनाओ ना.
The video is getting played, but audio we are not getting it out of it.
Shine light positions power. Facilitates the balancing of supply and demand, allowing adjustments to meet fluctuating energy needs. In this stage, high voltage step-up transformers are used to increase the voltage for transmitting power from long distances with the help of these towers. Some solar panels utilize that. It is used to store excess electricity generated during periods of sunlight for later use when sunlight is unavailable. Batteries are safely power system. Once the electricity generated by solar panels is converted from direct current DC to alternating current AC by the inverter, any excess energy can be stored in the battery bank for later use. A solar panel consists of multiple layers designed to protect the panel, with solar cells being the primary components. Solar cells are composed of semiconductor materials such as silicon. When sunlight penetrates the solar panel, it generates electricity, typically in the form of direct current DC. Friends, if you want to gain the knowledge how does solar cell generate this DC current, comment below. I will back soon. Thank you. Let's grow up. Never stop learning.
Then we have wind energy. Here we are harnessing the wind using the wind turbines to generate the electricity and the power of wind to generate electricity. Here, this also reduces with the wind. It reduces the carbon emission and contribute to environmental sustainability, less impact on environment. Let's have one video for this also, wind energy. Let's understand this.
Electricity is very important to people. Use it to power our homes, cities, and trains, and cars. ways we produce electricity is with the use of a generator. A generator is a device that converts mechanical kinetic energy into electrical energy. A wind turbine is a very large windmill that uses the kinetic energy of wind to spin its blades. The blades spin a generator that transforms the energy into electrical energy. Often, particularly in very windy places, many wind turbines are grouped together to form a wind farm. Wind farms can produce enough electricity to power whole cities. A big advantage of wind energy is that it is a clean and renewable energy source. It does not require the burning of fuels and does not produce harmful emissions into the air. There are some disadvantages of using wind energy. The large spinning blades on a wind turbine can kill or harm flying animals like birds or bats. They can produce loud sounds that can disturb natural environments and be annoying to people. And if damaged, wind turbines can be expensive to repair.
Then we have, we can generate the power from the flowing water. We have the dams, hydropower dams, wherein the energy is harnessed from the flowing water to generate electricity. For this also, we have a small video.
Conversion of water into electricity. It is a renewable energy source because the water cycle is constantly renewed by the sun. One of the first uses of hydro energy was from mechanical milling, such as grinding grains. But today, modern hydro plants produce electricity using turbines and generators. Mechanical energy created by moving water spins rotors on a turbine. This turbine is connected to an electromagnetic generator, which produces electricity when the turbine spins. There are two main types of hydroelectricity production: dams and run-of-river. Hydro dams utilize the potential energy from dammed water to produce electricity. A dam is a large barrier constructed to raise the level of water and control its flow. The elevation created by the dam creates gravitational force for turning the turbine when water is released. Some dams also contain an additional reservoir at their base where water is stored to be pumped to the higher reservoir for release when electricity is in demand. This is referred to as pumped storage hydro. The second form of hydroelectricity production is run-of-river hydro. Run-of-river still uses turbines and generators, but relies on natural water flow rates of rivers, diverting just a portion of the water through turbines. Because run-of-river hydro is subject to natural water variability, it is more intermittent than dammed hydro. There are various sizes of hydro plants that produce electricity. Large hydro, greater than 30 megawatts, small hydro, 100 kilowatts to 30 megawatts, and micro hydro, less than 100 kilowatts. The Hoover Dam in the United States is a whopping 2,074 megawatts, which is enough to serve 1.3 million people. Among energy sources, hydropower holds the largest share of worldwide electricity production. Hydropower has several benefits. It is a cost-competitive form of electricity, even though the initial building cost can be high. It is quite reliable compared to other renewable options and pairs well with other sources as it can be used as baseload power. In some cases, dam reservoirs can also help with flood control and be a reliable water supply for communities. There are also some concerns with hydropower, especially when it comes to large dams. Damming a river has a major impact on the local environment, changing wildlife habitats, blocking fish passage, and often forcing people in riverside communities to move out of their homes. In addition, dam failures can be catastrophic, claiming the lives of those living downstream. Hydro plants are also not completely free of greenhouse gas emissions. As with most forms of energy, carbon dioxide emissions happen during construction, particularly due to the large quantities of cement used, and plant matter in the flooded areas makes methane, another greenhouse gas, as it decays underwater.
Then we have the fourth one that is known as biomass energy. Here, let us understand what is biomass first. Biomass refers to the organic remains of plants and animals. Here, the organic waste of the plants and animals can be directly burned into heat or generate the energy, or it can be converted into biofuels, like which are like, for example, like biogas, biodiesel, like that. And moreover, biomass energy generation, it's a renewable type, because whatever the remains of the animals and plants can be regrown, can be utilized. Therefore, it is a type of renewable energy source. Whereas if you take the fossil fuels, wherein fossil fuels are the remnants or the remains of the ancient plants and animals which are buried under the layers of earth for long years. Now that can be converted, that can be after the long duration, that can be transformed into the fossil fuels. And these fossil fuels are not a renewable energy, because it takes millions of years in order to again regrow the animals and plants like that. So biofuels are not renewable energy sources. Biomass are renewable energy sources wherein we can directly convert into biofuels like biogas. But then the leading country which utilizes the biomass, for example, we have Brazil. In India also we use the gobar gas. And in Brazil we use the sugarcane biofuel industry. That is the leading country for the best example for the biomass energy generation. Coming to the fifth one, which is known as geothermal energy. Here we utilize or harness the heat from the Earth's crust. The crust of the Earth has developed the heat, and that heat is being utilized to generate the electricity. It's a type of renewable power, renewable energy produced. Now let's see one small video for geothermal energy also. How the energy is being harnessed.
Relaxed in a natural hot springs pool. You see the old faithful geyser blasting hot water into the air in Yellowstone National Park. But have you ever thought of where all that heat comes from? It comes from deep beneath the surface of the earth, and it's called geothermal energy. And we can use it to generate clean, renewable electricity. Okay, here's how geothermal works. Heat from the Earth's crust warms water that is seeped into underground reservoirs. In some places, when water becomes hot enough, it can break through the Earth's surface as steam or hot water. This usually happens where the Earth's crust or plates meet and shift. In the past, taking advantage of geothermal energy was limited to areas where hot water flowed near the surface. But as geothermal technologies advance, we can leverage even more these natural, renewable energy sources. Engineers have developed a few different ways to produce power from geothermal wells drilled into the ground. Have a look at this. It's a dry steam geothermal power plant, and it's the most common type of geothermal technology used today. Underground steam flows directly to a turbine to drive a generator that produces electricity. Pretty straightforward. Another geothermal technology is called a flash steam power plant. The pump pushes hot fluid into a tank at the surface where it cools. As it cools, the fluid flashes or quickly turns into vapor. The vapor then drives a turbine and powers the generator. The primary cycle plant works differently. It uses two types of fluid. Hot fluid from underground
Hello, sir. Please unmute the in-charge email ID. Hello, excuse me, sir. Please unmute yourself. Yeah, okay, fine now.
Thank you. Now, is it audible now? Okay.
Yes,
Now,
yes, sir.
just now we have seen geothermal energy, where energy is being extracted from the heat which is present in the crust of the earth, and that can be utilized for generating electricity. It has been greatly utilized in the countries like Iceland, extensive geothermal utilization. And the thing is, because of this geothermal energy, sustainable energy, it has minimal effect on the environment, which has some pollution effect on the environment. Now, coming to the sixth one, which is ocean energy. Here, we can extract the energy, we can utilize the energy from the high waves, tides, and thermal gradients. Now, this has been widely utilized in Australia. One of the university, which is known as Australian Federation University, recently they have approached in Hyderabad also. So they are calling for the research and development work and projects for projects in Australian Federation University, wherein ocean waves are being taken into consideration and energy has been utilized. That is one form of energy, ocean energy, from which electricity can be extracted. The leading country, of course, is South Korea, wherein tidal energy projects have been highly utilized. Now let's go to the other topic, which is the benefits of sustainable energy. I have told you in the very beginning. Always we have to remember the economical benefit, the environmental benefit, and the long-term benefit. We will see one by one. Environmental benefit. What do you mean by the environmental benefit from the sustainable energy management? The thing is, it should be it should reduce the pollution. If you take the greenhouse gas emission, wherein this is the effect, whereas the gases are released in the atmosphere, above the earth. These gases, what they do is they extract the heat from the sunlight, but these gases prevents the backflow of heat from the earth to the outer space, that is the out of the atmosphere. That means these gases prevent the backflow of the heat. So what happens because of that, the atmosphere of the earth surrounding the earth, the temperature increases, and due to that we have the global warming. Okay? So in order to not to affect or pollute the atmosphere, we have to take into consideration the environmental benefits. So if you go for the sustainable energy management, the first and the foremost important thing is we have to consider the environmental benefit. Means we have to reduce the pollution. The more polluting gases, if you take a greenhouse into consideration, the most polluting gases, atmosphere polluting gases are, we have carbon dioxide, we have methane, we have nitrous oxide. These are the gases which have the capability to absorb the heat, but they prevent the backflow of heat outer the atmosphere. Okay, so environmental benefit is the foremost benefit. Then comes the economic benefit. Whenever the economic benefit comes into picture, the thing is it has to be cost effective, means low cost. It should be for the long term, but without affecting the cost. The cost should not be high. Social benefit. What do you mean by the social benefit? The social benefit means it should increase or enhance the standard of living. Standard of living. Once a living, it has to. Standard of living means it should be free from pollution, free from other polluting gases. Long-term benefits. Definitely, sustainable energy ensures long-term energy availability and reduces vulnerability to energy price fluctuations. As I've given the example of CFL and LED, wherein why we go for LED, the light-emitting diodes in industries, in companies, in order to go for the long-term benefits. So sustainable energy emphasizes more on these factors: environmental benefits, economic benefits, social benefit, and long-term benefits. The countries which are showcasing the above benefits are Spain, because of which there is a job hike in solar energy sector. If you take Canada, we have hydropower benefits. In Kenya, geothermal energy in rural areas. So that is the why we go for geothermal energy, because in Kenya lies in the zone wherein we can get the heat from the Earth's crust easily. Then definitely, whenever we have benefits, there are certain challenges in sustainable energy management. The challenges are, if you take, I'll once again take the example of LED and CFL. Initial cost of LED is high when compared to CFL. Similarly, installation of all these solar, if you take the wind, if you take the biomass, all the renewable energy sources or sustainable energy sources, the initial cost is expensive. But long term, if you go for the long term, the cost is effective, low cost. Similarly, you can go for the technological limitations. Whenever we go for the digital one, whenever I go for digital meters, there is always storage of data problem, and efficiency of renewable systems need improvement. Regularly, the efficiency has to be improved in order to maintain the effectiveness of the system. So there are certain technological limitations also. And moreover, because the lack of public awareness is there, the farmers, the urban area, local rural areas, people should be known, should be provided with the knowledge of sustainable energy benefits. The benefits initially, what they think is their land is being taken, but because of the sustainable energy, the pollution, the environment, everything will be maintained properly. So lack of knowledge and resistance to change. There are many people who are reluctant or hesitant to go for the change. They want to be with the conventional sources. They want to go on. They don't want to change themselves. So there are lack of hurdles in many countries, and it is not like that. The people are given the independence. You cannot have a sustainable energy project wherever you want. So the areas where we can go for the sustainable energy management, like tidal, wind power, solar, where we can absorb much of heat, the people has to be educated regarding this sustainable energy. Otherwise, it is very difficult. Then there are certain policy and regulatory barriers. Every country has their own government policies. There is not a collision of collision of policies, or joint policies or joint regulatory organizations in order to go for the sustainability. Because the future is for sustainable energy development, we have to go for the policy and regulatory barriers are also a limitation, or are also a challenge in many countries. Then, as I've told you, energy storage issues. The energy storage, if you take the olden days, we used to have the analog meters, but right now we have the digital energy meters. There are certain important advantages of going for digital devices, digital storage meters, or wherein we can go for the data loggers, everything. But the thing is, the data storage is the issue. You have to store lakhs of gigabytes of data regularly, and it has to be reutilized, and that is a challenge also. Then the next topic is the role of educational institutions. What the educational institutions has to do in order to make these sustainable energy projects or renewable energy projects known to the people, the benefits of these projects, and the thing in order to avoid the global warming, in order to avoid utilizing fossil fuels, reliability on the fossil. Always we are reliable on the fossil fuels. So in order to have a change, in order to change the paradigm from non-renewable energy sources to renewable energy sources, the education has to be taken a leading role. The education has to take the leading role. In each country, we have the government education, the private educations. So the educations, what they have to do is, the institutions, what they have to do is they have to conduct the campaigns, workshops, seminars, FDPs, like the AICT is conducting this FDP. Because of this, the faculty will be knowing about the importance of sustainable energy, and because through faculty it can be conveyed, the message can be conveyed to the other industry people, other students, and it can be passed on to the other students and other knowledgeable persons, and it can be passed on to the rural areas also. So the educational institutions should take a leading role in order to conduct the awareness and education programs for the sustainable development energy management programs. Then, in fact, in order to have research and development, the sustainable energy has to be incorporated in our curriculum also. We have to introduce these future demanding topics to be included in our curriculum. If it is included, then research and development can be done. And the faculty has to definitely encourage the research scholars to take the sustainable energy technologies. There are lots of programs, lots of projects which can be taken, which can be utilized for sustainable energy. They can go for the solar, they can go for the wind. They can, if they are lying in the area where wind is very low, they can go for the solar projects. If these two conditions are not there, if they are near to the seashore, or they can go for the ocean. They can go for the wind also. They can go for the hydropower technologies and geothermal. If they are lying in the very hot zone, they can go for the geothermal energy projects. And definitely campus sustainability projects. I can give an example of my own campus, where I'm the principal and I'm the coordinator for this AICT. We have a biodiversity park. Recently, it has under the supervision of our Honorable Vice Chancellor, Professor Syed Ainul Hasan sir. We have started one biodiversity park. The area was a barren area. It was not utilized. And how we have converted, how our engineering section, led by Dr. Iqbal Khan, is the assistant professor in Civil Department of Polytechnic Hyderabad, how along with his team, engineering section team, has converted this barren land into a biodiversity park under the supervision of our Honorable Vice Chancellor. I'll give an example. I'll show a video wherein how the sustainable projects can be implemented within the campus, within the institution, within the colleges. So let me show that. This biodiversity pond cum rainwater harvesting pond, it has been named recently. So just now I've shown a video of our university biodiversity park cum rainwater harvesting pond, which was taken up by our engineering section, under the supervision of our Honorable Vice Chancellor, Sir, Professor Syed Ainul Hasan, Sir. The area just now you have seen, it is about 10,000 square meters, and we have a walkaway length of 500 meters surrounding the pound. The width of the walkaway is 20 feet. The depth of the pound is 5 meters, and we have planted 1,500 new plants, and we have utilized the surrounding grill, the fencing with our scrap material, and we have utilized that water. We have taken the water from the RO plants from the different hostels, 12 boys hostels and girls hostel. Approximately 40,000 liters per day, the RO water is taken into this pond, and we have not destroyed the rocks. The rocks are not disturbed. We have utilized those rocks, and we have 12 borewells of university. Borewells of university are surrounding the pole, and the capacity of pond to hold rainwater is about 11,400 cubic meters. That much of capacity it can sustain. Then we have many fruit plants also we have planted, like guava plants. We have 100 guava plants, 100 mango plants, 150 lemon plants, 150 new chiku plants, that is known as sapota plants, new papaya plants 15, and 200 new rose plants. So we have converted a 10,000 square meter land which was unutilized, which was not utilized, into a biodiversity park which has become the center of attraction in our university. That is an example of a sustainable project which comes under the institution. So Maulana Azad National University has taken a leading role converting the barren land into a, you can say, a biodiversity park. These are the global examples. We can take the Stanford University, wherein we have the whole campus is known as a renewable campus. And in India, we have IIT Madras, which is, as soon as you enter IIT Madras, you can see solar powered campus. Now, coming to the future prospects in sustainability, research scholars, faculty can take up this one. We can have smart energy systems. As soon as there are many participants which are from electrical background, you know the difference between the grid and smart grid. One-way communication, two-way communication, and smart grid, we utilize the data loggers, we utilize the digital devices. And if you take the microgrids, we go for the minor scale, small scale area. We can utilize the microprocessor based distribution system, whereas if you go for the local distributors are there for in smart grids. So smart energy systems are being utilized with the help of the use of artificial intelligence and IoT. Okay, then these areas that also can be explored. Then we have the storage problem. In order to overcome the storage problem, data storage problem, we go for the advanced energy storage solutions, innovations in battery technologies. Recently, we have seen the transformation in electric vehicles and electric cars and vehicles. So there is a transformation. There is a large storage of data can be used for a good battery technologies. Then decentralization energy sources. Earlier, if you take the electrical grids, there was no decentralization of energy solution. But if you take the microgrids, if you take an off-grid, we have decentralization of energy system. Then increased policy support. Now many countries, they are joining hands in order to go for a strong framework, joint framework, and government also stressing upon putting lots of interest on sustainable energy projects. We can see in the case studies how Indian government has taken sustainability projects, mainly in solar, in wind, and other areas. Global collaboration. Recently, in the Paris Agreement, many initiatives have been taken in order to go for the policy for sustainable development. And UK also, they have started sustainable development goals, wherein it has started in 2019. Now, because of this SDG goals, there are many workshops, seminars going throughout the globe in order to encourage for sustainable development projects. Now, we'll take some of the case studies of India's sustainable energy management. India is also leading in sustainable energy management. Okay, so first we go for the first one, that is, you can see the solar park which has been taken up by Karnataka Pavagada, Karnataka government, one of the largest solar parks in the world with a capacity of 2015 megawatts. It's a big one, huge one, largest solar park which has been taken by the Karnataka government. The key features are it is spread across 13,000 acres. Public-private partnership model involves leasing land from farmers. Very difficult task, taking leasing land from the farmers, ensuring steady income for the locals. Then the main outcome, the impact of this solar park is, because of that solar park, solar energy, the energy which is the heat which has been absorbed from the sunlight, the carbon emission has significantly reduced. Because of the carbon emission, we have the greenhouse emission effect. Okay, so because of the solar power, solar energy, solar parks, this has been greatly significantly reduced in Karnataka. Provides clean energy to millions of houses. And the key takeaway of this solar park at Pavagada, Karnataka is successful large-scale solar infrastructure with community involvement. Then the second one is the Gujarat Solar Power Initiative. Gujarat is the first state to launch a dedicated solar policy in 2009. Key features: Charanka Solar Park, 600 megawatts capacity, rooftop solar initiatives across cities. The output, the impact for this is it promotes widespread adoption of solar power, created employment opportunities. The key takeaway of this Gujarat Solar Power Initiative is effective policy implementation drives large-scale solar adoption. Then, and moreover, the government of Gujarat is also encouraging, motivating people to go for the rooftop solar projects, rooftop solar panels, which can be utilized for the utilization for hot water and for the kitchen and for the other purposes. Encouraging, government is encouraging and giving the subsidized rates for the solar panels. Then we have the third one, Cochin International Airport. This is the first airport of India where world's first fully solar powered airport. We have a solar powered airport. Entirely it is by solar energy. The airport is being powered by the solar energy. Key features are 50,000 solar panels installed across 45 acres. And the airport solar power generates 40 megawatts of power. And the output is it saves 300,000 tons of carbon emissions annually. And it also reduces dependence on traditional energy sources using the fossil fuels, the conventional methods. Okay, so 300 tons of carbon emission is being saved. The key takeaway of this Cochin International Airport is renewable energy integration in infrastructure can lead to carbon neutral operations. Then fourth one, we have Delhi Metro. I think many of you have seen that Delhi Metro is being energy efficient and renewable integration. The Delhi Metro Rail Corporation integrates solar energy and energy efficiency measures. The key features is rooftop solar panels on metro stations, energy efficient regenerating braking systems. The impact is 60% of energy requirements met by renewable sources. Significant reduction in carbon emission. The key takeaway of Delhi Metro project, Rail Corporation project is urban transport can play a critical role in sustainable energy management. Then we have a national electric mobility mission plan launched to promote electric mobility and reduce oil dependency. Key features, incentives for electric vehicles. Now you can see the government of Telangana has going to start 10,000 electric buses. Likewise, many states has gone for the transformation from conventional fuel vehicles to diesel or petrol vehicles to electric vehicles, because of which there is a great reduction of carbon emission and through faster adoption and manufacturing of electric vehicles, charging infrastructure development. The output, the impact is increased adoption of electric vehicles, reduction in urban pollution levels. The key takeaway of National Electric Mobility Mission Plan is policy-backed initiatives can accelerate sustainable transport solutions. Next one is waste to energy plant, Delhi. From waste, from scrap, we are getting the energy. That's what the plant has. It is based on sustainability. Then we have environmental sustainability. Okay. So based on those sustainability, these projects are plants have been developed. The key takeaway of this waste to energy plant is integrating waste management with energy production, which will definitely address multiple urban challenges. Then next one is Ujala scheme, that is Unnat Jyoti by affordable LEDs for all. Just now, in the very beginning, I have told you about the benefits of using LEDs when compared to CFL. The overview of this project is nationwide initiative to replace traditional bulbs with energy efficient LEDs. In our university also, most of the CFL bulbs tubes are being replaced by LEDs, and their duration, their brightness, their output, their span, it's much, and they are more efficient when compared to CFL. The key features are distributed 360 million LED bulbs, and this data has been taken. It's the last year data. 360 million LED bulbs have been distributed by the. It is the initiative of the Government of India which has been taken. Okay, and significant reduction in energy demand. The output is annual savings of over 47 billion kilowatts. Less energy, it takes less energy and more output. There is less input and more brightness. And I have also told you that the impact on environment is almost zero when you go for the LED. Whereas if you go for CFL, the impact on environment is hazardous because the chances of mercury emission. And naturally, reduction of over 38 million tons of carbon emissions annually. Because of that, it has reduced the carbon emission. Just now I've said the greenhouse gas emission, out of which the carbon dioxide, nitrous oxide, and these are the methane. These are the gases which are known as major greenhouse gases, which prevent the backflow of heat from the Earth's atmosphere into the space, which causes the global warming. Because of the global warming, you have seen lots of changes in the global seasons and global. We have the unusual snow falling in many areas, and there are we have environmental changes, many environmental changes in many areas. So the key feature of this Ujala scheme is affordable, accessible technology can drive large-scale energy efficiency. The last one is International Solar Alliance. It is the joint alliance founded by India and France to promote. That's what this is the very good example, wonderful example where countries are collaborating and going for the solar energy, that is sustainable energy. Jointly, they are going for solar energy. And the key features are collaboration among 121 solar resource rich countries. Focus on technology sharing, finance, and capacity building. Its impact is output is mobilized significant investment for solar projects, enhanced global partnership in clean energy. The key takeaway of International Solar Alliance is international cooperation is essential for global sustainable energy goals. Then finally, what we have seen is what is energy. Let me brief once again what we have done, what we have seen in the introduction to sustainable energy management. I have started with the first one, that is energy management. Energy is nothing but a process, a systematic process of monitoring, controlling, and optimizing energy with the minimum effect on environment. Okay, if this energy management is for the long term, for long term duration, that is known as sustainable energy. And sustainable energy management has three important things, that is environmental sustainability, social sustainability, and economic sustainability. Environmental sustainability means we have to prevent the environmental degradation. How to prevent the environmental degradation means polluting the environment. We have to prevent the pollution of the environment. Then we have economic sustainability, means we should have cost-effective sustainability project. And the third one is social sustainability, is the sustainability must be such that the standard of living should increase. One should feel comfortable or increase in standard of living. These are the three things which sustainable development energy management has: environmental sustainability, economic sustainability, and social sustainability. And we have seen the three principles of sustainable energy: energy efficiency, use of renewable energy sources, environmental energy sources, economic viability, innovation technology. Then there are many types of sustainable energy sources. I have touched 6 ones. First, I've gone for the solar energy and how the solar energy is being utilized. I've shown a video, YouTube video. Then wind energy, how to harness, how to get the energy from the wind. For that also, I've shown a small video. These two, solar energy and wind energy, to the large extent, they contribute to environmental sustainability, to reduce the carbon emission. Then I've shown the hydropower, wherein the power can be harnessed. We can get the energy from the flowing water. For this also, I've shown one small video where how the power is being extracted from the flowing water. From the you have seen that potential energy of water is being utilized. Then we have seen the biomass energy. I have given you the difference between the biomass and the biofuels. Biomass and the fossil fuels. Biomass is renewable energy, comes under renewable energy, whereas fossil fuels are not renewable energy sources, because in order to get the fossil fuels or remains of animals and plant, it takes millions of years in order to get those remnants. Therefore, fossil fuels are not renewable energy sources, whereas biomass, the organic waste of animals and plants, are sources of renewable energy. Then we have gone for the geothermal energy. The countries wherein the temperature is very high, we can go for the energy that can be extracted from the crust of the earth, the heat which is being taken into consideration. Because of that heat, we get the energy. Then we have seen the ocean energy. This energy is harnessed or extracted from the high tides, waves of the oceans, wherein I have given the example of Federation University, which encourages researchers to go for the projects which are based on ocean energy, extracting energy from waves, tides, and thermal gradients. Then finally, we have seen the benefits of sustainable energy management. Benefits means environmental sustainability. Benefit means the environment should be pollution free. Economic benefit means cost effective. Then we have seen social benefit means one should have a standard life. Then we have long-term benefits. Sustainable energy ensures long-term benefits. In fact, the challenges are initial installation of these sustainable energy sources. We have technology limitations, public awareness challenges are there, policy and regulatory barriers are there, storage challenges are there. In order to overcome these challenges, we have gone to the role of educational institutions. Throughout the globe, we have institutions. Those institutions can take the leading step in order to encourage, in order to give knowledge to the farmers, to the people, in order to go for the sustainable energy rather than for relying on the fossil fuels, which is very dangerous. Then we have seen the future prospects. The research scholars, the faculties can go for the smart energy systems, advanced energy storage solutions, decentralized energy solutions, increased policy support, global collaboration. Then we have seen eight case studies of India's sustainable energy management. Okay. So finally, I conclude, sustainable energy is very important for greener and more resilient future, economically, environmentally, and socially. And definitely sustainable energy belongs to those, the future belongs to those who harness sustainable energy today. If you go for sustainable energy today, then definitely our future will be bright. Sustainable energy is not an option. It has become compulsory. It is necessity. It has become a necessity. If we avoid sustainable energy now, then we will be in trouble in future. So I thank one and all. Any question and answers? You can contact me on the given email ID, use_LACT@yahoo.com. Website, our university website is banu.edu.in. So this is about the sustainable energy management.
Participants, if you have any queries, you can ask with the speaker now.
This is the first session. That this is an introduction to sustainable energy management. Later on, the sessions will be the advancements in sustainable energy management and environmental protection.
Thank you, sir.
Thank you. Thank you.
On behalf of the organizing committee and all the participants, I express my heartfelt gratitude to Dr. Mohammed Yusuf Khan, sir, for delivering such a thought-provoking and enlightening session on sustainable energy management. So your detailed insights into sustainable energy sources, key principles of energy management, and the challenges and opportunities in this field have been incredibly enriching. The practical case studies and your emphasis on the role of educational institutions in promoting sustainability has provided a clear roadmap for contributing to a greener future. We are truly grateful for the time and effort you dedicated to making this session a success. Thank you for sharing your expertise and inspiring us to be more proactive in our journey towards sustainability. Thank you once again, sir. Now, second session. Before starting off with the second session, we'll have a break of 5 minutes. Then we'll start off with the second session. Vamshi sir, are you there?
Again.
Hi.
Vamshi sir, have you joined?
Yeah, good evening.
Good evening, sir. So participants will be starting off with the second session of the day.
Can I just see the presentation? I will share it.
Yeah, please. Please share the screen, sir. Meanwhile, I'll introduce you to the participants. The resource person for the second session is Dr. Vamshi Krishna. And it is my honor to introduce our esteemed speaker for this session, Dr. Vamshi Krishna, currently serving as a Senior Technical Officer at the CSIR National Geophysical Research Institute, NGRI. With 16 years of rich and research and development experience, Dr. Vamshi is a highly accomplished expert in cutting-edge technologies. He holds a BTech in Electronics and Instrumentation from JNTU Hyderabad and an MTech in VLSI and Embedded Systems from Cochin University, Kerala. His research interest spans a wide range of advanced topics, including drone and UAV technologies, embedded systems and cyber physical systems, emerging VLSI trends, sensor electronics, magnetic and electromagnetic methodologies. Dr. Vamshi's profound knowledge and hands-on expertise make him a leading figure in his field. We are privileged to have him here today to share his insights. Now I would like to invite Dr. Vamshi Krishna, sir, to kindly take over the session.
Thank you, madam.
Thank you, sir. You can please start the sessions.
Okay. Good evening, all of you. So before I am going to the topic, I would like to express my best wishes and congratulations to the entire coordinating team, particularly Maulana Azad National Urdu University Director and team, and the coordinator Dr. Muhammad Yusuf Khanji and Ms. Fatima Madam Ji. And also I thank AACT ATAL Training Program Committee for giving this kind of opportunity, for making this program to be happen, to conduct this kind of programs.
Thank you, sir.
So today coming to the topic, 1 second. Hello. Yeah. Okay, okay. Presentation we are unable to see?
Yes, sir. We are not able to see the presentation.
Okay, okay. One second. Stop sharing. One second. I will just see. So I should select full screen, share full screen, huh? Yeah, entire screen. Full screen. But okay. Can you see my presentation now? Okay. So no, from where I see there is a present now button is there. So yeah, okay, entire screen. Yeah, now I am able to. Yeah. I think now you are able to see.
Yes, sir.
Yeah. Thank you. So once again, good evening to all of you. So the today's topic is energy storage systems and innovations. So basically, one related to energy. As I am working in engineering from past 15 years, we are working on a research and development area, especially in energy sector. You can say mineral exploration is one of the area NGRI is doing R&D for exploring the exploration of minerals under our Mother Earth. So where some of the very crucial and important minerals like uranium exploration, these are the one of the area where we explore for the net across the nation to utilize the mankind. So in that point of view, coming to the today's topic, energy storage systems and innovations. So I will briefly go to the fundamentals like what is energy and why you need to store and what are the kinds of energy storage systems, how this will be utilized in our societal developments, and what are the case studies and applications, and what is the future of the energy storage systems. These are the things we will discuss in coming session. So now coming to what is energy. So you can see energy is defined as the ability to do some work. So with energy only, we will be able to do any kind of work, and energy can be found in many things and can take different forms. For example, kinetic energy, potential energy, chemical energy. These are the kinds of energies. And also energy is never lost, but it can be converted from one form to another form. This is the one of the typical feature of the energy. Now, another question is that why you need to energy storage is required. So because see, the energy is needed to secure for the human mankind and reliable for example, you take as a reliable electricity supply. We need electricity supply 24 hours a day. And also need to make a more use of renewable energy resources such as solar and wind, because we are lacking of electricity storage in our country, and not only throughout the world also. To reduce our reliance on non-renewable energy sources like fossil fuels such as oil and gas. So we depend on the multiple alternative resources where we need to store the energy and utilize for the societal applications. So coming to conversion of excess electricity into different forms of energy, it can be reconverted into electricity within minimum losses. This can be done to reduce the gap in supply and demand of electricity. So always the production as well as consumption will have a lot of band gap where most of the time we won't be able to meet the demand, but supply is lacking, particularly for the energy sector. So it can be applied to both conventional sources of electricity and renewable energy also. So coming to electricity storage systems, low power applications in isolated areas, essentially to feed transition and emergency terminals, medium power applications in isolated areas, and network connection applications with peak leveling, and power quality control applications. These are the areas where we can use electricity storage systems. And coming to the world net electricity consumption, when the survey happened at 2002, they have estimated kind of kilowatts hours is required energy. Coming to 2025, roughly 26K of billion kilowatt hours are needed. This is the kind of consumption has happened for the whole net electricity consumption. So coming to renewable energy potential in India, you can see from the picture the total reserve of renewable energy potential in India, roughly around 8,96,603 megawatt. Out of this, most of the energy comes from the solar power, and next will be the wind power, and in very few will be hydropower and biomass power. So coming to our India, nationally, what is the energy balance? So this is, even though it is a bit earlier source of information, but even now also there is a lot of, as I told you, there is a huge gap between the consumption and production of the energy, and as well as storage of the energy. So coming to what is the importance of these energy storage systems? So first, for renewable energy sources and variable outputs, energy buffering, and importance in present context, and why we need this kind of technologies and devices, particularly to store this energy. So then coming to what are the different types of energy storage systems? It can be classified as mechanical energy storage system, magnetic, thermal, and chemical energy storage systems. So why we need to store, and what is the value of the storage, and where we utilize this kind of storage? So these are the four applications where we use this kind of storage energy, particularly residential consumers like our home, electricity supply, and commercial consumers like industries and grid operators and utilities. These are the applications where we utilize this kind of storage energies. So from this picture, you can see both the sides. It is clearly visible that there is a renewable energy and non-renewable energy. So the renewable energy is generated from wind, geothermal, water, solar, and biomass, etc. So at the same time, the non-renewable energy is generated from oil, coal, and nuclear and natural gases. So we'll see what is the difference between renewable and non-renewable energies. So renewable energy, these sources of energies can be used again and again, and these types of sources are inexhaustible. And particularly the advantage with the renewable source of energy is that it does not pollute atmosphere. It protects the environment. So what are the examples of renewable energy sources? Solar energy and wind energy. Coming to non-renewable source of energy, it cannot be used again and again, but the sources are exhaustible and cannot be renewed. The problem with this non-renewable source of energy is that it causes atmospheric pollution. Our environment will be spoiled because of this non-renewable energy sources. Example like coal, petroleum, and including even, you can say example as the petroleum pollution from the automobiles also is creating the environmental pollution. So use of renewable electricity generation and improved energy storage technologies have several benefits. So using renewable electricity generation, these are the benefits as a security, a more efficient grid that is more resistant to disruptions, and environment. It decreases the carbon dioxide emission from a greater use of clean electricity, and economy wise, increase in the economic value of wind and solar power, and strengthened competitiveness in the clean energy race. And also it creates a lot of job opportunities, particularly a new income sources from rural landowners and tax revenues for particularly for wind and solar development, because the wind and solar developments will happen at a rural areas where we have a lot of lands are supported, and a lot of rural landowners will be supported to develop this kind of energy sources. So coming to what are the types of energy storage. So it can be variety of types of energy storages, like biological, you can call starch, glycogen. When it comes to chemical, hydrogen and biofuel and liquid nitrogen. And comes to electrical category, there are capacitors, supercapacitors, superconducting magnetic energy storage. And under mechanical category, you can say compressed air energy storage, flywheel energy storage, spring gravitational potential energy storage device, hydroelectric energy storage. And electrochemical, you can call batteries, flow battery, fuel cell, ultra battery. Out of these types of energy storage systems, few of them we will see in detail what are the advantages, how it operates. These things we'll see in coming slides. So also thermal, under thermal, these are the types of energy storage systems like ice storage, molten salt, steam accumulator, solar pond, hot bricks, serogenic liquid air and nitrogen, seasonal thermal store. These are the types of thermal energies. So what are the variations in energy demand? So it's already discussed that the demand for electricity in the utility system is varies in hourly basis, daily basis, and season to season. So say for example of electricity. So electricity demand will always vary depending on the hourly basis and daily basis, and also season wise, because see in summer we use a lot of electricity, but whereas winter we use less kind of demand for the electricity. And what are the solutions for this? Because we can increase the efficiency of this and reach the demand and supply gap. So the interconnected network is one of the solutions, and use newer plants used for base load and older plants for additional loads, and construct not expensive, low infrastructure small plants, and also use energy storage systems. These are the solutions where we can reach the demand by supplying the energy to the common needs. So, as I discussed different types of energy storage categories, under that the technology types, if I divide into broadly into 4 types, particularly as a 4 features, the technology, what kind of technology, like batteries, flywheels, electrochemical capacitors, and hydro and compressed air energy storage, and how the theory of operation happens, and state of the art technology, and what is the cost projections. These things we will see in detail. So coming to the first technology, batteries. So everyone is very familiar with the batteries, as everyone is using the batteries and technologies, even from your smartphone to the automobile and other applications based on batteries. Many societal applications are running. So the battery storage energy chemically and uses electrochemical reactions to produce electricity at a fixed voltage. So what are the pros and cons of these batteries? So basically it's a convenient voltage characteristics and convenient sizing. So because of sizing only we are able to use in smartphones and other computers and other many gadgets where what we daily in our daily life we use. And what are the cons? I mean, the disadvantage of this one. So the battery life cycle is very limited, and voltage and current limitations and requiring complex series and parallel systems often present environmental hazard. Sometimes it blasts us. So these are the issues, major issues we face with the batteries. So particularly to increase the efficiency of the battery, we use series and parallel integration with the batteries and try to improve the power of the system. So battery application suitability, batteries are suitable for applications that require supply of relatively large amount of energy storage, that is greater than 1 megawatt hour over long periods of time, 15 minutes or more, where rapid recharge is not necessary and where maintenance can be reasonably performed. They are not especially suitable for environmental sensitive sites, remote locations, or applications that require rapid discharge and absorption of energy. These are the limitations. So from the picture we can see, I think many of the people aware of the battery, because battery is a very routinely used technology at present lifestyle. So at the bottom you can see there is a series of batteries connected to increase the power of the required amplitude. So when it comes to the different kinds of battery technologies, starting from lithium ion, lead acid, so many different kinds of battery technologies, the life cycle is very limited. So out of that, the lithium ion gives the best voltage current characteristics, where it can support the requirements as per the power needs. So coming to one of the category, lead acid batteries. The lead acid battery is the oldest known type of rechargeable battery and was invented in 1859. This battery usually have several in series connected cells, and each delivering 2 volts and each consisting several spongy pure lead cathodes, positive load oxide anodes, and 20 to 40% of solution of sulfuric acid that acts as an electrolyte. So what are the advantages? and disadvantages. And advantages comes to easy and therefore cheap to produce, easily recyclable, very high surge to weight ratio, capable of delivering a high jolt of electricity at once, which is why they are so suitable as a car starters. It's a mature technology, more than 150 years of experience and development has happened already. And when it comes to the disadvantages, it's very heavy and bulky and rather short-lived. There are environmental concerns, although safe. Lead is very toxic and exposure can cause severe damage to the people and animals, and corrosion caused by the technical reactions. These are the disadvantages of lead-acid batteries. And coming to lithium-ion batteries, so lithium is the lightest metal, and at present the lithium-ion batteries are nowadays very frequently used batteries because of the maximum power efficiency with these batteries, and it's a material with lightest metal with the highest potential due to its very reactive behavior, which in theory makes it very fitting as a compound for batteries. Just as the lead acid and most other batteries, a lithium-ion battery by definition use chemical reactions to release electricity. So what are the advantages of lithium-ion batteries? So advantages are, as I told, frequently used at present lithium-ion batteries. So highest energy density in commercially available batteries with huge potential, and provides higher voltage per cell as lead as 2 volt, but this is 3.7 volts compared to 2 volt lead acid battery, and low energy loss, only about 5% per month, and lithium and graphite as source are available in large amounts. So these are the materials we use. And coming to disadvantages, it's very expensive. That is the reason nowadays all electrical vehicles they use lithium-ion batteries. I think 40 to 50% of the price of the goes to the lithium-ion batteries where they use in electrical vehicles. So that's why it's very expensive, and complete discharge. If the battery completely discharges and destroys the cells, so we should not discharge completely these lithium-ion batteries. You need to recharge when it comes to at least 20% of the battery level, and it deteriorates even if unused. If you are not using also, the life cycle will come down. And the most important thing is that the lithium is a flammable in contact with atmospheric moisture. So this is one of the concern with the lithium-ion battery. So what are the other batteries in development? So redox flow battery. This is a battery which is in the development. These batteries technically are similar to conventional batteries, except that the electrolytes, there are different forms using 1 or 2 different fluids, and it can be exchanged, meaning that if the battery is discharged, the fluids are replaced with loaded ones. So the fluids will be replaced. This concept could, in theory, become very handy for electric cars, as you could charge your car simply by refueling, just as you do now. So if this kind of batteries comes up, so we can change the fuel in the battery and it can be reusable. So another kind of battery is sodium battery. The liquid sodium sulfur battery is yet another type of battery in development, but already operational in some countries like Japan. About 250 megawatt of sodium battery power have been installed there, and 5 sodium batteries have the advantage of relatively high density with up to 240 watt-hour per kg, as long as lifespan of 10 to 15 years, and high efficiency of 75 to 90%. But they need to be operated at high temperatures, that is 350 degrees, to get the sodium liquid. So these are one of the concern, but it has the very potential applications. and it can generate the huge megawatt of power. So another kind of batteries in development is zinc air battery. Just like the lithium air battery, the zinc air battery uses air as a second component. Zinc air has been a focus in development for a while because of its safety aspects and potential in density, but was dropped due to the low efficiency and short life cycles. Two independent companies claim to have solved these problems. So we have to see how the zinc air batteries will evolve, because it is particularly for the safety point of view, which is very useful to the societal applications. So another technology is conversion of electrical power to the gas fuel. So when using surplus power from wind generation, a concept is sometimes called wind gas. There are currently 3 methods in use. All use electricity to split water into hydrogen and oxygen by means of electrolysis. So by converting electric power to gas fuel, this is the one of the technology we use to convert power to gas. So this is the energy losses during this process. So another energy storage system is called thermal storage. As you see, a technology that stocks thermal energy by heating or cooling a storage medium, so that the stored energy can be used at a later time for heating and cooling applications and power generation. So by stocking thermal energy by heating, we can generate this kind of thermal energy, and later it can be utilized for the power applications. So what are the advantages of thermal storage energy? The thermal energy storage offers the option to improve output control for some energy technologies, able to reduce mismatch between supply and demand requirements, and low maintenance requirements. So it has low maintenance and reliable and well understood technology. And coming to disadvantages, the energy stored decreases with the time due to the heat losses. And also some storage technologies are still in developing stages. And also it is expensive. For seasonal storage, are needed big surfaces. So when you compare with the efficiency of different technologies, so the maximum and minimum efficiency, we are able to see lithium ion gives the maximum efficiency 95%, also flywheels and SMEC. So at present, lithium ion batteries are efficiently performing the requirements. So when it comes to what is the energy losses and cost, so their flywheels is taking, I think, up to 20% of per hour energy losses, but it gives the maximum life cycle. And lithium ion also, the life cycle is less, but it can give the better efficiency. But at the same time, you can see the per kilowatt hour, what is the cost. Now, what is the capacity and discharge time for energy storage system? So now you know how you are storing the energy in different methods and technologies. But At the same time, when you store it, what is the discharge time? So you see from the 10 kilowatt to 1 gigawatt of capacity, the discharge time is very high for the capacitors, particularly the capacitors takes more time for the capacity discharge time for energy storage system. So other methods are in between the range, where depending on the lifetime of the cycle, it varies. So when it comes to when you mix with the technology and in storage installations, how the efficiency varies from, as long as you see from 2011 to 2016. So maximum we utilize lithium ion and lead acid. These are the mostly, and by mixing the technologies, we are able to produce this kind of energy. So till now we have seen what are the kinds of different energy storage systems, and now we will see some case studies where this kind of energy storage systems, like see, the first project is that Purilia pumped storage project in India. It generates 900 megawatt instant generation. It costed around 2,953 crore, and it was commissioned in 2008, and duration is 4 to 6 hours. The benefit is that electric energy time shift and electric supply capacity. This is the real project, has already commissioned in 2008. The view of the Purilia project will be something like this, where there is a upper dam and lower dam, and in between they generate this hydro pump technology to generate the power. So these are the other pumped hydro storage plants in India. In Srisailam pumped hydro storage, that is up to 1670 megawatt, and Nagarjuna Sagar, it is of 700 megawatt, and Bihar pumped storage 150 megawatt, Sardar Sarovar pumped sector, that is 1450 megawatt. These are the case studies which hydro storage plants are developed in India. And when it goes to thermal energy, one of the example is that which was happened at Spain. It generates 150 megawatt and expected generates up to 495 gigawatt per year. It was commissioned in 2009. This thermal energy storage system was established at Spain. And another project is electromechanical energy storage system. This is the name of the project, is Beacon Power. The location is in United States, US. The plant capacity is 20 megawatt plant. And here they use 200 flywheel that provide frequency regulations services to grid operator. And it was commissioned in year 2014. And the benefit is frequency regulation. So till now I have seen the types of the energy storage systems and what are the technologies, and now and where the applications are established as a case study we have seen. Now we will see few technologies in detail, the energy storage systems. The flywheel is one of the energy storage. It is the form of momentum in a rotating wheel or cylinder. The principle is something like this. An electric motor spins the rotor to a high velocity to change the flywheel. During discharge, the motor acts as a generator, converting rotational energy into electricity. The power electronics are used to ensure that output voltage has appropriate voltage and frequency characteristics. And this is the principle. And the advantages of this flywheel is that high power density, high cycle life, and quick recharge independent, and power and energy sizing. And what are the disadvantages means low energy density, large standby losses, potentially dangerous failure modes. So what is the theoretical formula? The energy density is defined as a energy per unit, that is E by M equal to half V square. So where V is the circular velocity of the flywheel and the strength of the material and density of the material rho. So what are the properties of some materials used for building flywheels? So they use different kinds of materials: steel, aluminum, titanium, polymer, carbon fiber. These are the materials they use for building the. And advantage is very compact when compared to other storage systems. These flywheels are used for starting and braking locomotives. A flywheel is preferred due to lightweight and high energy capacity. It is not economical as it had a limited amount of charge and discharge cycles. So coming to this is another kind of compressed air energy storage system. So the air compressed and stored in a large underground spaces and is later used as a gas turbine generator. Smaller hybrid systems, that is less than 50 megawatt. And the advantage is huge energy and power capacity. And it has a lot of disadvantages like requires special location, expensive to build and maintain, slow start, and an unlikely candidate for distributed resources. So how it operates is that uses of peak electricity to compress air and store it in airtight underground caverns. When the air is released from the storage, it expands through a combustion turbine to create electricity. So what are the advantages is that fast startup, and the drawback is that geological structure reliance. So you need a very big geological structure to make this kind of setups. So another technology is called pumped hydroelectric energy storage. So water is pumped from low elevations to higher elevations to store energy as gravitational energy and run down through hydroelectric turbines to generate electricity. So there is a height difference between the elevations where the energy is generated because of this gravitational energy distribution. So what are the advantages is that huge energy and power capacity, and disadvantages are that requires special locations, expensive to build, not suitable for DER. So the operation is how it operates. It consists of two large reservoirs located at different elevations. During, as we have seen, the Pulipura project, there are up and down elevated reservoirs are there. During peak demand, water is released from the upper reservoir. Production exceeds demands, water is pumped and stored in upper reservoir. Pump is used as a combined motor and dynamo. The advantages are most effective with large capacity of electricity, that is more than 2000 megawatt. So geographical dependence. So it depends on the only geographically located reservoirs only we can apply this kind of setups. The capital cost is massive because of huge money has to be invested. And there is a problem with soil erosion, land erosion, and sheltering of dams. The another kind of storage method is the magnetic energy storage, called as superconductors. So superconducting magnetic energy storage system is a storage energy in the magnetic field produced by current flowing through a superconducting coil. This energy system principle is based on inductive energy storage in the magnetic field produced by current flowing through a superconducting coil. The DC current is converted to three-phase AC output using a solid-state power conditioning system. This is the principle. And when it comes to the pros and cons, higher power and quick recharge, and low energy density, and large capacity classes and expensive. At present, what is status currently viable for short-term power? For example, 1 to 10 megawatt power range, and proposed applications in PQ and transmission support. Several demonstration projects have shown the capability of the technology in these applications. High initial cost is the major obstacle for the technology. So ASEMEP systems store energy in a magnetic field created by the flow of direct current in a coil of superconducting material that has been cryogenically cooled. The principle is that at low temperatures, electric current encounters almost no resistance, stores energy in the magnetic field, environmental friendly and highly efficient. This is the advantage of the system. And these are the specification of the system. Depending on the peak field and ratio of the coil's height and diameter, the capacity of storage varies. So another kind of technology is the supercapacitor. This is one of the storage method. Here the capacitors is nothing but a use of thin film polymers for the dielectric layer, which creates the potential between the films. Carbon nanotubes and polymers are practical supercapacitors. In future, carbon nanotubes with ceramics is a technology which can be will be evolved slowly, and it reduces the effect of fluctuations and longer lifetime, which reduces maintenance and cost. So electrochemical and super ultra capacitors, also known as supercapacitors, ultra capacitors, are electrical double layer capacitors. Actually stores the energy in the electrical double layer at an electrode or electrolyte interface. So it is actually the advantages are high power density, higher cycle life and quick recharge, and cons are low energy density, expensive. Sloped voltage curve requires power electronics. Energy and power density of electrical supercapacitors. The energy and power densities of electrochemical capacitors fall between those of batteries and conventional capacitors. So when it comes to the status of these capacitors, currently viable for bridging power in the hundreds of kilowatt power range, smaller power range, long-term energy storage, applications of electrochemical capacitors for residential peak shaving is another application that is currently under consideration. Use of electrochemical capacitors for multi-megawatt utility applications that are require several hours of energy storage, particularly peak shaving and load leveling are the important characteristics of this technology, and it is not feasible at present. So what are the types of batteries when it comes to the electrochemical storage? The small capacities, lead acid batteries, and large scale. They use actually chemical reaction to do work on charge and produce a voltage between their output terminals. The efficiency of the cell is only 15%. So the working of lead acid battery is something like this. So when you compare the different types of battery energy storage systems, you can compare the lead acid, nickel, cadmium, and sodium sulfur, lithium ion, and other this one. So out of this, I think lithium ion having the self-discharge rate is very less, that is 1% approximately, and the power also it creates 200 to 315 in terms of power efficiency. Other can be compared So these are the comparison between the different battery energy storage systems. So when it comes to the installation of lead acid battery across the world, these are the year of installation. I think starting from 1986 till late 90s, these many lead acid battery storage installations have happened. And you can see the rated energy, which is of very nominal power. And underground thermal energy storage using methods of heat exchange like aquaphile thermal storage, usage of underground water, and duct thermal storage, usage of plastic tubes. So these are the underground thermal energy storage systems. So it has environmental impact also. The applications of thermal energy storage is that air conditioning. A salt hydrate acts as a cool heat sink for the air conditioner working fluid, and this is a method for the application of thermal energy. The stored heat is directed from the salt hydrate during night to heat the surrounding air. And the example is the sodium sulfate decahydrate. So this is the method of regenerative fuel cell storage system. A fuel cell is an electrochemical cell that converts a source fuel from combustible substance such as hydrogen, methane, propane, and methanol into electric current. This is the fuel cell definition. So a fuel cell is a device that generates electricity by a chemical reaction. Every fuel cell has two electrodes, one positive and one negative, called respectively anode and cathode. The reactions that produce electricity takes place at the electrodes. Hydrogen is the basic fuel, but fuel cells also require oxygen. One great appeal for fuel cell is that they generate electricity with very little pollution. Much of the hydrogen and oxygen used in generating electricity ultimately combines to form a harmless byproduct, namely water. So this is the way the power is generated using fuel cell. So as I told, it's a direct conversion between energy into electricity by burning fuel. It's a high efficiency, and the applications for the fuel cells are NASA and viable alternate petroleum engines. And what are the types of fuel cells? It is classified based on the operating conditions and various electrolytes used. Alkaline fuel cells, polymer electrolyte membrane, phosphoric acid fuel cells, molten carbon fuel cells, solid oxide fuel cells, regenerative fuel cells, as we have seen in the earlier slide. And what are the energy densities of some energy storage methods? When it comes to hydrogen, the energy density is something like 38 kilowatt hour per kg, and gasoline 14 kilowatt per kg, and lead acid batteries 0.04 kilowatt hour per kg, and flywheel hydro storage is around 0.3, and flywheel is 0.05, and flywheel earlier was steel, it was carbon fiber, and fused silica and compressed air. So the highest density is generated using hydrogen energy storage method, which is you are seeing in the at these figures. So what are the advantages? So no greenhouse gases, not much political dependence, more operating time. And disadvantages are storage of hydrogen due to high inflammable nature of H2. So metal hydrates and NH3 can be alternative. High capital cost due to platinum catalyst used in the process. So out of these energy storage systems, now the question comes, which is the better. So by comparing one method to another method as an energy storage system is pointless, because the reason was that only one thing. None of them are optimal for all purposes, because depending on the application, depending on the need, the technology and method and the energy storage system needs to be identified and to be utilized. So different storage methods and different in capacity and maximum usable storage time. These are the specifications where we need to choose according to the requirement. For large scale storage, underground thermal, pumped hydro and compressed air energy storage systems are preferable. But as we discussed, the name itself, it says the large scale storage. So we have a huge plant establishment needs to be made for this kind of systems, and large scale storage we can use underground thermal and pumped hydro and compressed air methodologies. Superconductors can store energy with negligible losses. So as you can see, superconductors in a sense like a capacitors. So even with this technology we are using in our smart applications also, this kind of superconductors to store the energy like batteries. And fuel cells are viable alternative to petrol engines due to their high efficiency. And flywheels have a narrow range and are not an answer for large scale operations. As I discussed, for large scale operations, and we go for the underground thermal as well as pumped hydro, compressed air methodology. So when it comes to the, you have seen different types of energy storage systems, why you need this kind of what is energy and why you need to store the energy, and other different types of energy storage, and what are the advantages, disadvantages, all these things we have seen. Now coming to what is the future of energy storage system, we should know now. So the energy storage evolution electrifies the future of renewables. So the more energy you can store when you use the renewable energy sources. So at the same time, the changing regulatory outlook also is important, and enthusiasm grows as a prices decline. So when it comes to the energy, it is cheaper prices. The development will go faster for this kind of applications. And what leads the next frontier of energy storage is another important question. So what types of storage do you foresee being instrumental in the grid of the future? So when it comes to the energy storage, so the highest right now is in the instrumental in the as a grid utilization. Electrochemical battery, we are using 63.4%. Particularly, you can give as example as our smart gadgets and electrical vehicles, automobile sector. So many, we can say, electrochemical battery based. And the second largest is pumped hydro, where you can store a lot of energy, but because of huge initial investment cost is there. But for larger storage requirements, this is the one of the best method to store energy. The next comes to the thermal energy, that is 19.30%. Thermal also one of the large storage energy method. In the fourth place, you can say compressed air is the method where we have 14.9%. and followed by hydrogen 13.7%, and flywheel is 9.9%, synthetic natural gas 5.6%, liquid air 5%, and rest of the natural renewable energies are somewhere around 19.9%. So for the sustainable development, so these are the things we need to see, particularly good health and well-being, affordable and clean energy, decent work and economic growth, industry innovation and infrastructure, life on land, climate action, responsible consumption and production, sustainable cities and communities, and life below water, peace, justice, and strong institutions. These are the sustainable development goals. We have to use energy as per the standards. In a nutshell, that when you come to the conclusion, the reliable and affordable energy storage is a prerequisite for using renewable energy. Energy storage, therefore, has a pivotal role in the future. So energy storage is the most promising technology currently available to meet the ever-increasing demand of energy. So these are the things we can conclude. The energy storage is very much important for the day-to-day human life cycle, and the technology needs to be developed in a faster way to reach the demand by supplying the energy to the various advanced technologies. That is the conclusion of the energy storage system and innovations. Thank you.
Thank you, sir. Dear participants, if you have any queries, any questions, you can ask the speaker.
Good evening, sir. It was a wonderful session, sir. Very good. My query is regarding medical practice. Now, people are about believing that
Can you make it a little bit clear? I am unable to hear you properly.
Sir, am I audible now?
Yeah, tell me.
Is it okay, sir?
Yeah. Is it fine?
Hello?
Yeah. Tell me.
Hello?
Yeah, can you hear me?
Dr. Sheikh, you are audible. Please continue. You're audible, sir.
I'm audible to you?
Yes,
Yeah,
sir,
yeah.
you're audible.
यस सर डॉक्टर शेख मोहम्मद रसूल साहब आप ऑडिबल है आप
Please
अपना
let me
क्वेश्चन
know that am I
रखिए
audible to you or not?
Yeah, you are audible.
Hello?
Dr. Sheikh, if there is any issue, technical issue with audio, you can post your question in the chat box. It will be answered. Kindly post your question in the chat box, sir.